Yeah. Tell me. Huh? Wow. Now you know Baylor, that one goes far. Other places, that's still something. Are you committed? Is that it?
But she got in.
You wanted to do TW2 or something. Did you tell me where you were going to do? Or my I did in my stuff, but you can open your no, because I want it so great. If you want something great, you have to put a colleagues.
I can finally send in my resume. I finished it days ago, but I forgot.
Yeah, go ahead. Wow. All right. That's like you. Just on Mondays and Thursdays. So today. Are you coming today? For corrections or for tutoring? All right. All right, let's put Chromebooks away. Okay, listen. This is your last full day of notes. Okay, and then we start semester exam review. No, you don't. Well, I guess we can do that. I don't know. Well, why don't you please? Maybe, yeah. I don't know.
Think about homework.
I didn't really think about that till right now, but anyways, maybe I'll count your semester exam review.
Yeah.
Would you do that?
Yes.
All right, fine. But you do have a semester exam regardless. You just won't have another unit test, is what I mean by that. So this is our last new topic. So let's put Chromebooks away and let's really lock in to try to finish out the year, all the new crap you've learned, and then we'll review next week. So what we are doing today, this is a little bit confusing, but if everybody really locks in at the beginning, then the next examples will go much, much faster. Okay, so we are going to be looking at a graph of f prime. And then we are going to be making determinations about what the graph of f that we do not have a picture of, what that would need to look like. Okay, so you're going to have to understand the connections between f prime, and f double prime. Okay, but you can do it. So let's look at your first example. Okay, this is a graph of what? F prime, so fill in the blank. This is a graph of f prime, but we're making conclusions about the graph of f, a graph that we do not have a picture of. Okay, so it says right here, f prime is above the x-axis on which intervals? So look at your picture. Where is it above the x-axis? What intervals? Okay, let's start at -8 since it's a circle, not an arrow. Okay, but yes, till here. And then it's above again until here. Is there anywhere else that it's above? The little tail right here. Very good. So your graph is above the x-axis on the interval from, we'll say -9 all the way till 3. Union, and then 8 to 9. Okay, now here's what that means. If your graph is above the x-axis, then the values would have to be positive. So I want you to write right here. Okay, if f prime is above the x-axis, then f prime of x is greater than 0. And you should know that f prime being greater than 0, or let's say positive, tells me that the graph of f must have been increasing. Okay, so think about if that makes sense. I'm going to say it one more time. The graph I'm looking at is f prime. When it's above the x-axis, f prime is positive. And we know that f prime tells us whether f is uphill or downhill. So if it's positive, then it would have to have been uphill. Even without me having a picture of f, I know that based on this graph. Now, let's do the opposite. Where is f prime below the x-axis? What interval? 3 to 8, very good. So fill in the blank. Okay, that my graph of f prime is below the x-axis on 3 to 8. And if f prime is below the x-axis, then f prime is also less than 0 or negative. And if f prime is negative, that tells me that f is decreasing. Okay? Now, f prime also intersects the x-axis. That is the same as an x-intercept. Okay, if it's intersecting the x-axis, that's an x-intercept. Can you tell me on this graph, what numbers does it cross the x-axis at? Okay, 3 and 8. Is there one more? Also -4. Very good. So let's put x equals -4, 3, 8. Now, that means that this graph f prime crosses the x-axis, then f prime of x needs to equal 0. And remember that in the first derivative test and the second derivative test, these had a special name. That remember, we would take the derivative and then set it equal to 0. What are those numbers called? Critical numbers. Very good. So your critical numbers for f are going to be the x-intercepts on the graph of f prime. Why? Because that's where your f prime of x is equal to 0. Okay, and with that information, I can now create a first derivative test. So give me a number line down here in that little space. And I want you to do your best to try to line your number line up with the graph. So what I mean by that is like let 0 be kind of lined up with 0. Okay, what were my other 2 critical numbers? Or 3 critical numbers, what were they? Okay, so -4 would be over here. 3 is here. And then 8 is over here. Okay, remember that we are going to determine the signs of f prime of x. And that's going to tell me what f would have been doing. All right. Before -4. Okay, look at your graph of f prime. Where is the graph of f prime? Is it in the positives or the negatives at the beginning of the graph? Positives. Put a little plus there. Between -4 and 3, where is my graph? In the positives or the negatives? So still positive. Okay, between 3 and 8, where is my graph? It's below the x-axis. That means it's negative. And then past 8, my graph ends up back in the positives. Now, if f prime is positive, remember what we said up here, that means that f would have been increasing or going uphill. So uphill, uphill. Okay, then what happens here at 3? My graph switches to go downhill. And then after 8, my graph goes back uphill. Okay, let's label what types of critical numbers we have here. At 8, is there a relative min, a relative max, or neither here at 8? This is a relative minimum at 8. Okay, what happens at 3? A relative min, relative max, or neither? At 3, it would be a maximum. Okay, what about at -4? Is it a min, a max, or neither one? Neither one, very good. So I'm going to call that an HT. Okay, that stands for horizontal tangent, and here's what that means. Your graph is gonna flatten. Okay, so picture, it's gonna go uphill, it's gonna flatten out, but then it's gonna keep going uphill. So a horizontal tangent isn't necessarily a min or a max. In this case, it's not either one. It just is gonna be flat for a second. Okay, so above tells me F is increasing. Below tells me F would have been decreasing. Now let's go on to the slope. Look at your graph. Okay, this is a graph of which function? F prime. Okay, so now I want you to write this little sentence. If we do the slope of the graph of F prime, okay, remember that a slope is the same as a derivative, yes? So if I am looking at the slope of this graph, that means really that's the derivative of F prime. What is that called? F double prime. Very good. So if I'm looking at F prime, the slope of this graph is F double prime for the original graph. So let's come down here. Let's fill in our blanks. Okay, the first thing it says is that F prime is increasing or has a positive slope on which intervals. So let's look at our graph. We're looking for the uphill or positive slope sections of the graph. Where does that happen? Okay, so from -4 until, make sure we're using the X value for that. What X is that? 0. So it does get up to 6, but remember it's -4 till 0. Where else is it uphill? From 5 until 9. You see what I'm saying? You want it to be just uphill. So think like it's a roller coaster. What parts are uphill? So if I start here, I'd be downhill, uphill I want, downhill I don't want, uphill I want. So it would be from -4 to 0, union, and then from 5 to 9. Okay, also notice we're not going to go to infinity because we don't have arrows on the end, we have endpoints. Okay, now let's think about this for a second. If F prime is increasing, that means the slope of F prime is positive, which means the derivative of F prime is positive, which means F double prime is positive. And what feature does F double prime control for regular F? We learned it the last 2 class periods. Concavity. So if F double prime is greater than 0, then F must have been concave up on those sections of the graph. Okay, now let's look for the sections of the graph of F prime where it's decreasing or it has a downhill slope. So look back at your graph. On what intervals is my graph downhill or has a negative slope? Okay, so 0 to, let's go past 3. When does it stop being downhill? 5. And then also -9 till -4. So list those 2 intervals. It'd be from -9 to -4, union, and then 0 till 5. Okay, now think about, this is a graph of F prime. So if F prime is downhill, then its slope is negative, which means the derivative of F prime is negative, but the derivative of F prime is called F double prime. So that would have to be negative. And if the second derivative is negative, then what must the original graph of F have looked like? It must have been concave down. Very good. All right, last little bit of this. I want you to go up to your graph and I want you to put X's everywhere that your F double prime, remember that's the slope, is not positive or negative, but where it's 0. So look at your graph and put little X's everywhere that your graph flattens out. So you should be placing X's here, here, and here. Okay, what are those X values that we just put the X's on? -4, 0, and 5 is correct. Okay, now let's talk about why those points matter. At -4, at 0, and at 5, my graph flattened out. And if we look at, let's just look at the first one. My slope changed from a negative slope to a positive slope. What would have changed on F? Versus C. Concavity, right? I would have gone from concave down to concave up. Then what is this called? Starts with the I. In. Not that. Inflection. No, not that either. Okay, it's an inflection point. Do you remember that? Okay, or sometimes it's called a point of inflection. Okay, but obviously those are the same thing. It's just the AP test does call it both. Okay, so all three of those would be inflection points or points of inflection. Okay, and the reason why is because at each of those X's that you placed, the slope of this graph changes sign. And the slope of this graph is really what? F double prime. Yeah? Okay, so let's come down here. Let's fill in those blanks. So we said the slope of F prime is 0. That means the derivative of F prime is 0. And we call that F double prime is 0. So what that means is your original graph of F is going to have concavity changes, which we call points of inflection. Or I'm just going to call them POIs because it's shorter. Okay, then it says you can use this information to create a second derivative test. So draw me another number line. My inflection points need to happen at -4. Now remember, we're intentionally lining our -4 in our second derivative test up with our -4 in our first derivative test. Okay, then also 0, which would be right here. And then 5, which would be, maybe that's a little too far, but I already did it. Put 5 here. Okay, now go back to your graph. F double prime is the slope of the graph that we're looking at on our paper. So can you tell me to the left of -4, was it an uphill slope or a downhill slope for this section? Look at the picture on your paper. Is it an uphill slope or a downhill slope? Downhill slope means negative. Between -4 and 0, what was the sign of F double prime, which is the slope of the graph that you're looking at? Positive. Okay, then from 0 to 5, back to negative. Then after 5, positive. But if this is F double prime, we know it controls concavity, which means my graph starts concave down, then it switches to concave up, then down, then up. So with the first and second derivative test, that's enough information for me to sketch what f of x must have looked like. So we did a tiny bit of this last class, and we're going to finish this today. So draw yourself a little graph here. Okay, and if you remember, trying to think who it was that someone had said, like, you're really just connecting the dots, right? Okay, I think DJ, I see you, it was you. Okay, but here's the problem. Last time you had little dots to connect. This time we don't have any points to connect. So all we can work with is the information from our first and our second derivative test. So last time we had a little bit more information than we have this time, but we can still do it. So the first thing I want you to do is prep your graph. Anywhere that you have a max, I want you to put a little top cap. Anywhere you have a min, I want you to put a little bottom, like a little valley. So where is my max supposed to happen at? 3. So 1, 2, 3. I'm going to give myself a little max, kind of like a little like top of a hill. Okay, then I'm supposed to have a min at what number?
8.
At 8. So we'll do 4, 5, 6, 7. We'll say 8's out here. And I'm going to give myself a little min. Okay, so give yourself a little valley that we know it's going to have to go down and then up to have a min. Okay, now don't forget that at -4, what happens? What does HT stand for? Horizontal tangent. So I know I need to have a flat spot, and I don't know exactly where to put it, but I'm just going to kind of guess and put it here. Okay, that I know it needs to go flat for a second, but it's not going to be a min or max. So I have a flat spot here, I have a cap here, and I have a min here. Okay, the last thing I want you to do before we start sketching is draw in little dotted lines everywhere your concavity should switch. So my concavity needs to switch at -4, 0, and 5. So I'm going to draw in a little dotted line at -4, at 0, and we'll say 5 is here. Okay. Now that we have our graph prepped, we're ready to start drawing. So to the left of -4, that's going to be increasing or decreasing. First derivative test says increasing. What type of concavity? Down. So draw me a little piece of a graph that's increasing, concave down. And you have to flatten out because we know at -4, the graph goes flat. Okay, next little piece. I'm only going to go from -4 to 0. From -4 to 0, am I going to increase or decrease? Increase how? Concave up. Very good. So I'm going to keep increasing, concave up. And make sure that your graph is kind of bent so that it's up like a cup. Okay, next little section of my graph is going to be from 0 to 3. From 0 to 3, am I increasing or decreasing? Still increasing, but what changes? Now I'm in a concave down section. So I'm going to keep going up, but I'm going to change the way it's bent. Okay, then at 3, what changes? My graph switches to doing what? Downhill. And what's the concavity? Down. So notice the first derivative test tells me I'm going downhill. The second derivative test tells me how to bend my graph. So I want to go downhill, concave down. That would look like this till 5. And then what happens at 5? I'm going to keep going downhill, but what's going to change at 5? Now we're concave up. So you're going to keep decreasing, but switch your concavity to up. Okay, then at 8, what happens? Now I'm going to be increasing or decreasing? Increasing how? Still concave up. So that is what the graph of F must have looked like. Now, a couple things that I want to say before we go to the next example. When you take a derivative, do you remember what happens to constants? They go to 0. You lose information when you take a derivative. So here's what I mean by that. When we're working from the derivative backwards to the original, you could not tell me how high this maximum has to go. You know there's a max, but if you drew your max way up here, or if you drew your min way down here, okay, all you can tell is the shape. Because when you take a derivative, you lose a little bit of information that you don't know exactly how high this max is or how low this max is. You just know the general shape. So as long as your shape is correct, okay, then you would get basically full credit on the AP test for it. Okay? Turn the page. Let's do one more. Hopefully this one can go a little bit faster. Yes, you may, sure. Okay, number 2. What is this a graph of? What function? This is a graph of f prime. And if this is a graph of f prime of x, remember we're answering questions about the graph of f, which is a graph we do not have a picture of. When is f prime above the x-axis on this graph? What intervals?
There again.
So the question was, when is f of f prime above the x-axis? So it'd be from -8 all the way pretty much until the end of the interval. Now, you could break this into 2 pieces, but you don't have to, so I'm not going to. So my graph is above the x-axis from -8 all the way until 9. And because f prime is above the x-axis, that means f prime of x is greater than 0. And what does a positive f prime mean for the original graph f? Increasing, very good. Now let's look for our sections that are below the x-axis. Where is my graph below the x-axis? What interval? -9 to -8. And if f prime is below the x-axis, then f prime of x is negative or less than 0. And anytime that f prime is less than 0, what does that tell me f must have been doing? Decreasing. Now, if the above sections are increasing and the below sections are decreasing, then when I'm on the x-axis, I'm going to find my critical numbers. So look at your graph. Where does it cross the x-axis? Okay, very good. -8 and anywhere else? Yeah, -2. So it'd be x equals -8, -2. Okay, that means that at those values, f prime of x is equal to 0, and they're critical numbers. Okay, using that information, I'm going to set up my first derivative test. -8, remember we're trying to line it up with the original graph. And -2. Remember, we're asking ourselves, am I above or below the x-axis on f prime? So for f prime, how does it start out? Above or below? Below means negative. Put a negative right here. Then the next 2 sections are both where? Above, which means positive. Okay, and a lot of times if I have a really long interval like this, I'll put more than 1 positive just to remember that whole thing is positive. Okay, now remember, these are the signs of the f prime graph, but they can tell me what regular f is doing. When f prime is negative, what was f doing? Going down or decreasing, very good. Okay, and then on the remaining 2 intervals, it's positive, which means f would have been increasing that whole time. Is -8 a min, a max, or a neither? A min, very good. Okay, at -2, is it a min, a max, or a neither? Okay, this is a neither. I'm going to call it a horizontal tangent because it will go flat, but it will not actually bend to give me a max or a min. All right, second part of the question, we want f prime increasing or decreasing. Look at your graph. List all of your increasing intervals. Okay, so I would just shade on your graph where it's uphill. So do that now, then we'll do it together. Okay, shade everywhere that this graph has a positive slope or is increasing. There should be 3 sections of graph that you're shading. Can someone tell me the first one? Okay, -9, I'm gonna go till -5. So -9 to -5 union. Okay, where's the next uphill? -2 to 0, very good. And then last one. Yeah, let's do 3 till 9. Okay, now if f prime is increasing, that means f prime's slope is positive, which means f prime's derivative is positive, which we call f double prime. And if f double prime is positive, what does that tell me about f? Concave up. Okay, next I'm going to be looking for the decreasing sections of that same graph. What will my decreasing sections be? -5 to -2. And then 0 to 3, very good. And remember that if f prime has a negative slope, then that means f double prime is negative. And if f double prime is negative, then I know my graph must have been concave down. Very good. Okay, last thing, find all of your flat spots and put X's there. Put X's there. How many flat spots should this graph have? 4 is correct. You should have 1 here, 1 here, 1 here, and 1 here. Okay, now remember that those are where f prime's slope changes sign. And remember that the slope of f prime graph is really f double prime, which means that those are points of inflection. Okay, list those values in your next part. So my horizontal tangents happen at x equals -5, -2, 0, and +3. And at those values, because my f prime graph is flat, my second derivative must have been 0, which means I could have a point of inflection. Okay, that being said, let's set up our second derivative test, and then we'll use both of our derivative tests to sketch our graph. So -2, make sure you line it up with your -2 on your first derivative test. You want those on top of each other. Okay, then 0 and 3. And then -5 we'll say is here. Now remember, if I'm finding the signs of f double prime, that's going to be the slope of the graph that you're looking at. So initially in the far left category past -5, how does my slope start off? As an uphill or a downhill? I think it's uphill, yeah? In your graph, that's uphill. Okay, because remember, we don't care about above or below. We care about the slope. It's going uphill. So that's a positive. Then what happens? Then it goes downhill. Then it goes which way? Back uphill. Then 0 to 3, it goes back downhill. And then after 3, it goes uphill. Okay, but remember, this is the slope of the f prime graph. Okay, from there, if those are the signs for f prime, that tells me everything I need to know about f's concavity. F must have gone from concave up to down like a frown, to up like a cup, down like a frown, up like a cup. Okay, from there, let's sketch our graph. Okay, remember, the first thing I'm gonna do is draw in any mins or maxes and any flat spots. So where should I have a min or a max? At what number? Okay, -8. And then I'm gonna draw myself a little valley. Okay, you don't know exactly how low to put it, okay, but just give yourself a little divot, because I know I need to hit a low spot there. Okay, at -2, what needs to happen? A flat spot. Okay, but it doesn't need to actually curve, so I'm just gonna draw in a little flat line like that. Okay, no other critical numbers from the first derivative test. We go on to the second derivative test. Remember, I'm going to give myself little dotted lines everywhere my concavity should switch. Where is the first place that should happen? Okay, -5. I'm going to give myself a little dotted line. Where else? -2. Where else? 0. And then one more. At 3. And then remember, when you draw your graph, you want to just compartmentalize it little pieces at a time. So I'm going to start with the graph to the left of -8. Should my graph start off increasing or decreasing? Decreasing how? Concave up. So draw your graph like that. It needs to be decreasing, that means downhill, concave up. Okay, then from -8 until -5, what switches? I'm going to start going which way? So uphill and still concave up. So draw your graph uphill and concave up like a cup. Okay, next little section, I'm going to pick back up at -5 and I'm going to go till -2. From -5 to -2, I'm still going uphill, but what changed? Concavity, now I'm concave down. Okay, then after -2, how far can I shade before I need to stop? Only till 0, very good, because at 0, something switches. What happens at 0? I need to be concave up until that point. So I'm going to be increasing concave up. That means my graph would have to look like that. Okay, for the rest of the graph, I'm going to stay uphill. Well, I have to finish their notes, but if you want to hang out till after that, then yes. Okay, so it's going to stay increasing the whole rest of the time, but I'm going to go concave down till 3 and then back to concave up. So let's draw the rest of our picture. We're going to go concave down and then back to concave up. Okay. Okay, and that is what your graph of F must have looked like. Is it confusing? Okay. All right, are you ready to try one? Okay, turn to the next page and you're gonna do that very next one. Yes, try it on your own. You can do it. This is a graph of F prime, correct? It actually was supposed to say, but it's just barely. What do you mean? So this one, you don't have the full. But just you're not gonna have to fill in all the blanks.
But that's the same thing. You're not necessarily. I'm telling you, I told you that I realized we were talking about that.
So remember,
Never been to Disney too.
Fine.
So that's. Right.
All right, are we ready? Ready for the next one? Good, okay. So what is this a graph of? F prime, you can fill in that first blank. And now we want to know where F would be increasing. Is this the graph of F though? This is what? F prime. So for F to be increasing, where does F prime? Not increasing. It needs to be above the x-axis. In the positive.
Oh, right.
Right? Uh-huh. So from -9 all the way until when does it go below? Uh-huh. And then there's one more little piece that's above. Yep. Okay, you want F to be increasing, yeah? Okay,
I was.
F is increasing, then F prime. Yeah. So
And then it's
positive.
Click the button, make one click.
That for F to be increasing. Look back here. Take for F to be
It's my
Yeah.
Oh, demons not that level of intelligence.
I don't care.
And then I would get you actually.
You know, it's kind of confusing.
Because with the way.
One F.
Okay.
Negative 0. Oh, go -9 all the way. So for it to be above, isn't it? Yeah. Remember, slope tells you about that double prime, not X.
That's
That's kind of confusing. That's where you have. You share, you go part A. So for F to be well, it's not above the whole time. So this is not.
How is that? Your name is on it, so. So it will be first.
So it goes uphill.
I'm not.
Your first
decrease would be. Oh, wait, no, the decrease would be 3 to 8.
Is that?
Yes, and then do your derivative test.
It's 8 to 4,
So it'd be -8, you can go past 4, because then it stays above, right? And really it should be. So when is it above? From -9 all the way until.
Sorry.
Wait, what would be said? Was it increasing from five?
Is this a man? Or not?
Hold on. We're doing, remember, it's above or below. This is F prime. We're checking to see if it's above. So it's -6, was it above or below before? Then it should be a positive. And then after that, what is it? Positive. I know they put the exact. Yeah, 3, so this should be a 3. And then at 3, what happens? It goes into the negatives until when? So this should be an 8. And then it should be a 5. Okay, then remember, that tells me that F would have had to be going which way at the beginning? Up, so we're increasing. Okay, then what? Increasing, then 8 is a min, max, or either. 3 has to be. And this one, yeah. Maybe erase that number.
You know, that's not even wrong, but you told everybody else to sleep.
Well, because just that's very.
My mom do like a screenshot of money they gave me, but her like you can tell she was happy, but not to the point that you can tell she has to.
Okay, y'all, just because I want you to have plenty of time to work on your homework, okay, I want to make sure your answer to the first part is right before you start sketching. So your graph of F will be increasing when this graph is above the x-axis, which should be from -9 till 3, and then 8 to 9. Your graph should be decreasing from 3 to 8. Okay, where it says justify, everybody listen up to this part. Okay, the AP graders will not take a little sign chart as your reasoning. You need to say it in real like math stuff. So because I know the graph is increasing because F prime of X is greater than 0. Now, if you would rather say F prime of X is above the x-axis, they would take that. Or F prime of X is positive would also be fine. Now, if it's increasing because F prime is greater than 0, what would my reasoning be for this part? Because F prime of X is less than 0. Okay, or if you prefer, below the x-axis or is negative would all be fine. Okay, for your next part, your critical numbers are everywhere that F prime of X, the graph you're looking at, is equal to 0. Okay, those would be your x-intercepts. So -4, 3, and 8 should have made your chart. -4, 3, and 8. Now, without me even drawing a first derivative test, because you should have already done it on your paper, what type is -4 if it's above, before, and after? Is it a min, a max, or neither? That should be a neither or an HT. Okay, because you don't truly have a sign change because you were above in the positives before and also above after. What type should 3 be? A min, a max, or a neither? 3 should be a max. Now let's talk about how I know. Because if I'm going from the positives into the negatives, my graph would have gone from a positive slope to a negative slope. That's a max. Okay, what about here at 8? What's the direction? Which way? From negatives to positives, which would have been a negative slope to a positive slope. That makes it a min. Okay. So let's do your justifications just to make sure that you understand how to do that for the AP test. So X equals -4. We said that it is a neither. Because F prime does not change sign. So my graph does go flat, but it doesn't actually switch from plus to minus or minus to plus. X equals 3. We said that was a relative max because F prime changes. Is it plus to minus or minus to plus for a max? Plus to minus. Okay, and then last one is X equals 8. We said that's a relative minimum because F prime changes which direction? So minus to plus. Very good. Okay, for the second part of your graph, you should be drawing your X's and then checking your concavity. Okay, keep going. You're doing a good job. Concave down uphill, okay, you're gonna keep going uphill. Let's switch to concave up.
Yeah, I think I'm really smart.
Yeah, so you're gonna bend. So still, it's gonna still be concave down, but you're gonna start. You're gonna ride this round. But notice, you're still going down. So your race. Here on. So you wanna stay.
You said you didn't want me to, I didn't know what I was, I want to. I thought about it, it's too easy.
So you're in this one. From 5 to 8.
What? You gotta do, like, what's the meaning of schedule?
Inflection points are good, this one changes sign. So we need the X's at the height. So basically, the things that matter like on this graph are points of inflection.
Say that.
You actually shouldn't have a word on it. Remember though, horizontal is here. So think about it like this. So. The X intercept. Yes.
First of all, I actually don't know why.
Negative 4, this should be. I think I would put 5 for this. Let me draw my derivative test and then I'll help. You're just needing to sketch it now. So try to set up your graph, that first step. You haven't done these parts yet? Okay, so concave up would be when F prime is increasing or has a positive slope. So where do you have a positive slope on your graph? -4 to 0 and 5 to 9. Very good. So -4 to 0 union 5 to 9. And then your graph is concave down where it has a negative slope on this graph. So that'd be from -9 to -4.
Oh, that's.
And then also from 0 till 5.
Because it's convex is negative.
Yeah, and what you could put is, let's put because F prime is increasing. Now, that is the same as has a positive slope. So if you prefer to phrase it that way, that is fine. And then my graph F would be concave down when F prime has a negative slope. What do we call that though, when F prime is? It would be decreasing, that's right. Okay, look up for your B causes if you need them.
I did the first one.
Your first derivative test should look like this. I'm gonna have to put mine over here because I haven't done them yet. So you should have had -4 and 3. And it went above, below. And then above. So it would have been up, down, up. Good? Okay, that's your first derivative test. Now let's do your second. So we had x's at -4. We had one at 0. And then we had one at 5, yeah? Okay, how does the graph start off? Uphill or downhill? So that's a negative. Then at -4 it goes uphill. Then back to downhill, then up. Remember, those signs tell me concavity. So it'd be concave down, up, down. Good so far? Okay, then to prep your graph. Okay, where am I gonna have a flat spot? What number? -4 needs to go flat. Okay, then at 3, what needs to happen? We need to have a little max. And then at 8, we need to have a min. Okay, then remember you want your little dotted lines in everywhere the concavity switches. So it would be at -4, at 0, and at 5. Okay, then from there, remember, it's just little chunk by little chunk. So to the left of -4, what am I doing? How? Concave down. So increasing concave down would be like that. Okay, then what happens from -4 until 0? Increasing how? Up. So it'd be like that.
On a Thursday?
Okay, then from 0 to 3, I'm gonna keep increasing, but what switches? Concave down. So I'm gonna keep going uphill, but I'm gonna change the bend so that it goes this way. Okay, then from 3 to 5, I want to switch to go downhill till when? 5 and I want to be bent down, so it'd be like downhill and bent down would be like that. And then from 5 to 8, I want to keep going downhill, but switch to concave up. And then at 8, I want to switch to uphill concave up, which would be like that. All right, look up to check your graph if you need to. Okay, remember, all you really care about with that is the shape. As long as your shape is good, you should be fine. Yes. Oh, we just have to finish one more, and then we'll do that. They would be above or below. Remember, when you take a dribble, you lose all this constant play. You don't know how high or low. You just know it has to go flat. All right. Okay, we just have to cover one more thing and it'll take like 5 minutes and then we'll be on homework. Turn to this page, please. I know, I'm sorry. Really sorry. Not quite the last, the front of the last. Okay, the last thing we have to talk about is graphs of F double prime. Okay, F prime is like a lot of the AP tests. F double prime is just a little bit. Okay, here's why. Remember how we said when you take the derivative, you lose information about all the y values? Yes. When you take the second derivative, you lose all the information about slope. So F double prime graphs, okay, read right here. They're very limited. All they can tell you is concavity and points of inflection. Okay, once you've taken the derivative twice, you lose too much information to know mins and maxes. All you can say are concavity and points of inflection. So this is a graph of F double prime. And remember the relationship. When F double prime is positive, F is concave up. This is a graph of F double prime. When is it in the positives? -9 all the way until -1. Because remember, being in the positives means above the x-axis. Okay, and then also here. So write down your graph of F would have been concave up from -9 all the way until -1. And then also from 4 to 8. How do I know that? Because F double prime is greater than 0 or above the x-axis. Okay, but notice that because this is F double prime, that's why you would just care about above or below for concavity. Okay, when is this graph below the x-axis? -1 to 4. Union 8 to 9. And it's because F double prime is less than 0. So if you're looking at an F prime graph, F double prime would be its slope. But if you're looking at an F double prime graph, you care about above or below again. Okay, points of inflection would happen here and here and here. At x equals -1, at 4, and at 8, because F double prime changes sign. Okay, but notice that for your F double prime graphs, you only care about above or below, and it can only tell you concavity. Okay. Do you feel like you kind of get it? Okay. Pull out your computers. We're going to do just the first question together. You have about 20 minutes.
I love the random person.
Oh, you like that? I like to go from sometimes cursive to print in the same word even sometimes. Just never know.
Yeah, for that.
Oh, y'all, your homework is called Don't Do This Yet, but that's it. It is Don't Do This Yet, that's it. Okay, just the first question.
Let's go. Let's get after it.
Okay, so that. Why do you ever log out, Doc? No. Just keep your Delta math always logged in. I know it's the don't do that. All right, first question. Because versus on the other graph, if you're looking at F prime, the way you get in that. It's kind of tricky. Okay, let's just finish up. Here we go. Okay, if I asked you to find f of -3. Okay, listen. Okay, this is a graph of f. Now, eventually, you're going to get to ones that are going to say you're looking at f prime, but this is regular f. What type of number is f of -3? Is it, and now keep in mind, f of -3 means a y value. So if I go to -3, what type of value is its y value? A positive. So in the drop-down menu, you're going to pick greater than 0. Okay, f prime of -3 refers to the slope of this graph, because remember, this is regular f. So looking at -3, what type of slope does that point have? Positive, so you want to pick greater than 0. Now, for f double prime, that's referring to the concavity of the graph. And if you read in the question, it tells you that the little green circles, okay, are referring to the points of inflection. Okay, so everywhere you see a green circle, that means the concavity is switching at that point. So if I'm looking at -3, do you see that you have a green circle there? What that means is your concavity switching from, what is it on this side? Concave what? Up to concave down. Then at this point, it must have been what? 0. Because remember, in order for you to switch signs, you have to cross 0. So that one would be equals 0. So if it's a graph of f, there's no tricks. F is a y value, f prime is a slope, f double prime is a concavity. Okay? And then now you should be able to do the rest of it. Okay, really use your time wisely and ask for help if you need it. Yes, ma'am. Oh, it's me? Okay, great. And?
Oh, I also like. I said this most like 3. I can't read it. I need to take
Move your foot.
Okay.
Move it.
But did you do it on Texas time now?
Good boy.
Yeah.
Okay, yeah, so then I can upload it to all. Do you know when you need it on?
Do that.
Oh, okay, but like, the reason I asked is I'm going camping, and I will not be here, but I'll be in the woods.
Wait.
I'll be back Monday. Oh. Because you can have it. I like to be one with nature in the woods.
Yeah, just better.
Yeah, I mean, I can do it before next semester, but if you need it like by December. 10, then I would say, you know? So if it's an F, original graph, an F, it has a y value. S prime is the slope, S double prime is the downside. Now, when you go to an S prime graph, remember that everything would change. That's where you'll have to think about F prime is a F double prime is because it's like you're looking not at the original dash equation, you're like looking at the base equation. So if you're looking at an S prime graph, then S prime will be above or below. And F double prime will be below. Okay, so try some questions, you can do it, yes. Yeah, and notice that on a grind job, that's when it's 0 because the concavity is switching. But -5 is being a little up like a conversation. Okay, good idea, let's see. So, okay. Put your pencil on 6. Okay, 6 could be, oh no, well, let's see for okay, so what's your Y value? It's negative. Okay, what is that? And then. Minus is 0. You're putting it in order for the long way. So negative is the smaller, that's what you're doing. Is this who's jacket?
No.
Who's tiny baby jacket is this? Is it you?
Oh, no.
Wyatt, are you doing part 1, part 2, or both? Just since I'm about to go out of town, let's go ahead and start on that one. Because that way you'll know exactly which ones are right and wrong. It's just I didn't know if you needed it like not like immediately, but like yeah. By the end of the semester, it's fine. But you know, ask me about it here and there. Keep it on my mind.
I'll actually do Thursday.
It's not always like that. No, like,
You did wrong?
Okay.